In this lesson, you will learn about the outer loop controls used by the autopilot to control the aeroplane about the primary or roll axis. Included in this will be heading select and hold, VOR localizer interception and tracking, and lateral navigation known as LNAV. To use the guidance functions of the autopilot for long-term navigation and speed control, the autopilot needs to have current navigation and air data information fed into the computer. When the respective pitch or roll command mode is engaged, the computer couples the target value with the current value to generate a steering command to the inner loop. The following systems or components provide continuous inputs to the flight control computers. The Central Air Data Computer, CADC, supplies current airspeed, Mach, altitude, and vertical speed. Attitude reference is supplied by a vertical gyro, or an inertial navigation, or inertial reference system. A magnetic heading reference system supplies current heading. ILS and VOR receivers supply radio navigation steering information. The flight management system supplies computer-generated route tracking for pitch and roll control of the autopilot, and speed and thrust commands for the autothrottle system. And finally, the radio altimeter supplies height information for autoland and autothrottle. Firstly, we will examine typical guidance functions for the roll channel. With Autopilot A in command mode, the flight mode annunciator will show command in green. Now any roll guidance function can be selected. The roll functions available are heading select and hold, forelock tracking, and lateral navigation or LNAV. If you wish to look at any of the enlarged images again, just click on them. Heading hold is a function that will cause the autopilot to maintain the current heading when pressed. If it is pressed during a turn, the autopilot will roll the aircraft wings level and maintain the heading it rolls out on. It is an easy way to interrupt a turn if required. This function is not available on the system we are demonstrating. Heading select is a very common function that allows the aircraft to fly to and maintain a heading selected with the heading selector. The heading selector is a rotary selector, which, when turned, will position a heading index or bug around the outer scale of the compass rose on the HSI, EHSI, or navigation display. It will also show the selected heading in the heading window above the heading selector. Also associated with the heading selector is a bank angle limiter, which may be rotated to manually select a limiting bank angle, typically from 5 to 30 degrees, in increments of 5 degrees. It may also have an auto position, when the flight control computer will calculate a limiting bank angle that is appropriate to the mode in use. For the example shown, the aircraft is currently on a heading of 090 degrees, and the heading selector is selected to 130 degrees, with a limiting bank angle selected to 30 degrees. When heading select mode is engaged by pressing the heading select button, the button will illuminate, and heading select will be the annunciation in the roll window of the flight mode annunciator in green to signify engaged. The computer will calculate the heading error and roll the aircraft into a right bank to maintain the limiting bank angle as the aircraft turns. As the heading error reduces, the computer will start to roll the aircraft back towards wings level. The aircraft rolls out on the selected heading of 130, with the heading bug aligned with the current heading on the compass display. The aircraft can be controlled by turning the heading selector left to turn left and right to turn right, as long as heading select mode is engaged. If the change in heading is small, the aircraft may not reach the limiting bank angle. The aircraft can automatically capture and track a VOR radial or a localizer beam by using the VOR selection. In this example, we will capture a VOR radial. Localizer mode will be described in the Autoland operation lesson. A VOR beacon is a ground-based radio navigation aid, which transmits information continually on a VHF frequency, having a range of around 150 nautical miles. VOR stands for VHF Omnidirectional Radio Range. The VOR receiver in the aircraft receives the transmission and converts the radio signal into range and bearing displays on the navigation display, or HSI. The course selector on the mode control panel allows a course to be selected with respect to the tuned VOR beacon for the pilot or the autopilot to intercept and track. There are two course selectors, one at each side of the mode control panel. The course selector on the left of the mode control panel is associated with a navigation receiver number 1 on the left of the glare shield or left of the center console, referred to as box 1. The right-hand course selector is associated with navigation receiver number 2 or box 2. In this aircraft, box 1 is coupled to Autopilot A and box 2 to Autopilot B. In this example, we will allow the autopilot to capture and track a course of 090 degrees from a heading of 130 degrees and fly inbound towards the beacon along the 270 degree radial. When the frequency of the beacon has been tuned, a course of 090 degrees is selected on the course selector. This positions the course carriage on the HSI, EHSI, or navigation display. The deviation bar and scale show the angular deviation of the aircraft from the selected radial. When flying manually, the pilot would assess the rate of closure to the required radial by looking at the movement of the deviation bar and turn the aircraft at the appropriate time to intercept the radial. To enable the autopilot to automatically capture and track the radial, once the beacon has been tuned and the course selected, press the VOR button. The VOR lock button is illuminated and VOR is displayed in white underneath the heading select annunciation to signify that the VOR mode is armed. As the aircraft closes towards the selected radial, the flight control computer is assessing the radial error rate. The autopilot also knows the angle through which it has to turn the aircraft, because it knows the current heading, 130 degrees, and it knows the course required, 090 degrees. The aircraft will reach the point of beam capture when the autopilot needs to start turning the aircraft. At this point, VOR mode becomes engaged, signified by the VOR annunciation moving up and turning green, to replace heading select as the engaged mode. The light in the heading select button will extinguish. The aircraft will now bank to the left and turn to intercept the selected radial as the radial error reduces. The aircraft will be rolled back wings level to maintain the magnetic course at the beacon, the roll channel of the autopilot being controlled by deviation signals from the radial. The heading selector takes no further part, but will be positioned by the pilot to the current heading when the aircraft is established on course. If it is required to fly over the top of the VOR beacon and continue outbound on the same course, then the aircraft must fly through an area overhead the beacon, known as the cone of confusion or cone of silence. In this area, the received signals are unmanageable, and the autopilot can no longer follow the selected radial. As the aircraft enters the cone of confusion, an over-station sensor causes the autopilot to temporarily maintain the current heading, typically for 2 minutes, while the aircraft transits through the cone of confusion. The autopilot can now track the 090-degree outbound radial until it is required to change course. The lateral navigation function of the autopilot allows the autopilot to follow a computer-generated flight path derived from the flight management system. The flight management computer has a database of navigation information, including standard approach and departure procedures, radio navigation aid information, and standard waypoints. A waypoint is a point on the surface of the Earth, designated by a latitude and longitude. Waypoints and VOR beacons are typically co-located to allow for either methods of navigation to be used across land. But of course a waypoint could also be a point over the ocean. The pilot can also manually enter any latitude and longitude to produce a unique waypoint. Waypoints can be collected together and saved in the flight management computer as a route with a sequence of as many as 120 waypoints. Standard routes are saved in the computer and can be accessed through the FMS Control Display Unit, CDU. When the required route has been identified from a list, the pilot can select it to activate it. It then becomes the active route and will be pictorially displayed on the EHSI or navigation display. The FMC database is updated on a 28-day cycle to ensure the latest amendments to any route or navigation information are being used. So if you are going to fly a scheduled flight from Stansted to Faro, you will be able to use a company standard route that had been entered by your operations department. You will be able to add a standard departure procedure for the departure runway and an approach procedure for the arrival runway. After takeoff, when the autopilot is engaged, the lateral navigation button can be pressed to engage lateral navigation mode. This will cause the autopilot to fly the aircraft sequentially through the active route series of waypoints. To navigate the aircraft, the flight management system needs the support of an inertial navigation or inertial reference system. The inertial navigation system knows where it is, and the flight management system knows where it is going. So between them, they can provide accurate long-term navigation through a sequence of waypoints, flying the aircraft along great circle tracks, which give the shortest distance between 2 points on a sphere. The advantage being that the system is self-contained and requires no information from outside the aircraft. It can, however, use information from outside the aircraft to check and update its position. The flight management system can auto-tune a pair of VOR beacons and use the distance from each to determine position, or use a satellite positioning system input. During this lesson, you have learned about the roll modes of the Autoflight system, including heading select and hold, forelock, and lateral navigation.